Well, I thought I'd do a little bit of filming on this. Can't be asked to crack the proper camera out, but I just noticed that. Look, see the little LED just occasionally flashing. Anyway, so this is currently just got some crappy YouTube no content ID playlist playing. This is a hell of a lot of work, actually, is what this is. So this is a dual channel valve based microphone preamp with functions, a lot of functions. So yeah, I'm going to just do a shaky phone camera walkthrough of what's going on. So first things first, if you're watching this, you probably have some inkling of electronics. Well, valves require high voltage. Musicians and high voltage do not go well. They like to drink whilst they're performing, they like to trip over cables, they like to stand on stuff, they like to put stuff on top of stuff. I didn't want the power supplies, these are just some transformers on the bench running it. I didn't want the power supplies in the same case as this because this is very high gain and it'll pick up a shit ton of noise. So I want the power supplies remote. However, I don't want to be running some kind of super high quality, high voltage rated connector that, you know, you're going to have an umbilical between the power supply and the device. This. I don't want like some 220 volt rated cable. So it runs off of a 12 volt AC supply and a 35 volt AC supply. Very craftily done. It is quadrupled on the board to the high voltage. So a quick overview of what's on the board before I just delve into the schematics. This is, I need something pointy. So this is all input. These are all voltage regulators. So this entire section around here is power supply. This is the valve input stage. This is the differential amplifier and balanced output driver, and this is part of a signal detecting. Just shows you if you've got signal, shows you if it's clipping, which is what this LED occasionally lighting up does. So I'm driving the ass off this. So let's look at the schematic. So you don't really have the room for it on this bench, so you're just gonna have to make do. Might just turn another light on, that might help things. Anyway, so that's the input power supply for the HT. So see, voltage quadrupler, one side of the 35 volts comes in here. It gets rectified via a voltage doubler into about 100 volts, and then these caps and diodes quadruple it into about 220 volts. Craftily, the center tap 110 volt point, that goes off for the phantom power and various other circuits in the 220 odd runs the valve stage. So that's the HT regulator for the valve stage. You can see there's some additional RC smoothing going on just to take any ripple out. Simple enough. So it's a Zener based regulator. Regulated output is about 160 volts, and there's a turn on delay here, and then lots of protection diodes. This is for the 48 volt supply. So again, some resistive capacitive smoothing, another Zener based regulator, 100 volts in, 48 volts out. So we've already got a regulated supply for 48 volts, which is very clean. There's then an additional regulator here, which takes it down to 30, which is what's running all the op amps. And that itself then goes through a capacitance multiplier, feeding into some op amps, forming a virtual earth circuit for the halfway point, because all the op amps are running off single rail 30 volt DC. So this is regulated, smoothed, and then smoothed again. Incredibly quiet supply, lots of protection diodes. Again, you can see this is all just for decoupling and bypassing for the op amp stages. And finally, the power supply for the heater. So 12 volt AC comes in, rectified, smoothed, bit of RC filtering. Yeah, that's 220 ohms, that is right. So yeah, I've actually put a 1 ohm resistor. There's a jumper on the board here. I've actually changed it to a 1 ohm resistor. It gives a perfect 12.6 volts for the heaters, because it was a little high, it was about 12.9. And again, some diode protection on there. So that's just the basic power supply section. Let's have a look at the preamp. So this is a little more complicated. This looks really dark on my phone. It's hard to see what's going on. So because it's designed for microphone preamp, it needs to have phantom volt pass through on it and also phantom volt output. So this is where the microphone would connect in here and here. So there's some capacitors blocking DC. That's all on that side, same on the other side. The actual gain stage is, that's actually 10K, not 4K7. So anti-log pot connecting the two cathodes together for increased gain. The 560 ohm resistors are bootstrapped by the capacitor, not capacitor, the transistor having a gain of like 0.999 something is an emitter follower. That's the equivalent of about 50,000 ohms anode load. That simultaneously modulates the voltage on the upper resistor here, which then is amplified also in the transistor, but then is in a feedback loop with each valve. Full power gives a back gain of 100 dB. Differential rejection, I can slam a 2 volt RMS signal into it and get absolutely nothing out, so it is working perfectly, and that's on all gain settings. Bit of local decoupling. Very crafty. If you noticed, I shouldn't show it on the power supply. Let me grab that. The power supply, although it is a positive regulator, the positive output actually connects to 0 volts, meaning it's regulated minus 12.6 volts output rather than positive. The 12.6 volts is also fed via some more RC smoothing to the cathodes of the valves to make sure that, so this is going to be at about plus 1 volt. This is at about minus 8, so this transistor has plenty of voltage swing. If I try to run this off 0 volts, then I could only go down to like just above 0 volts and then it would clip. So that would be no good at all. So yeah, that's the gain stage. Your differential amplifier and output buffers, there's a mistake on this schematic which translated into a mistake on the board. I was wondering why I wasn't getting any good differential rejection and getting some uneven gain on each valve stage. If you look here, this wire bridge should be here for this capacitor across this op amp. However, this one, rather than connecting here, should connect to here. This bottom one is just the inverter for the balanced line output. This is the actual differential amplifier. So obviously with this connected, it wasn't seeing even impedances, and therefore when the signal was the same on both lines, it wasn't rejecting it because there was different levels of signal. So again, lots of diode protection on the input and output, some capacitors, so obviously these have the 15 volts or so across them at all times. Whether the phantom's on or off, this has the 48 volts across it. So yeah, there's a lot going on here. Oh, what's this? All right, this is both of the, bear in mind there's 2 of the gain stages and 2 of the differential amps on each, one for each channel. All the regulators and everything are shared between both. So this is for the 48 volt. So the board has its own 48 volt regulator on it. You can't just connect the 48 from the input to the output. It needs some way of detecting the 48 and turning it on. So this is where the output goes to a mixing desk. This is designed to be in like a stage room where the microphone's at. This sits before the long cable run to the desk, and you add your gain with this, and then you've got a line level signal going into the desk rather than a mic level. So if you turn the 48 volt on the desk, it's seen this transistor is driven into saturation. That goes to this transistor. It then goes to a few 6K8 resistors as normal to the outputs. The 48 volt from the desk actually would normally power an LED, sits here, but should the LED come unplugged, there's just a low voltage Zener diode just to clamp the base voltage at this transistor in that eventuality. Again, just more protection. Oh, something's just popped off there. I've lost a channel. Clip leads everywhere. And this is the signal detection. So as you can see, it's just 2 comparators. The input signal comes in. They're set this one's set it incredibly low, about 10 millivolts. The other set it 4 volts, whatever it was, I can't remember now. So yeah, again, these just connected to regulated 30 volt rail. You can see 22k and 22 ohm. That's a big voltage divider. This one sits about a third of the rail voltage. So yeah, 8 volts or so, whatever it's going to work out to. So if the signal on this exceeds this diode conducts forward, charges this cap up. This transistor turns on, drives the LED, which plugs in there. On this one, if the signal's a lot higher, same again happens, and on either of these, when the signal's below the threshold, this cap just slow discharges through the base of this transistor and the LED just goes out. And that's it. That's it in a nutshell. I thought I want to keep that sweet and simple. You can see it's driving now, just phone's powering it. If I can't really get to it, can I? If I shove the yellow here into the orange, I'm then giving it a full common mode signal. You can see how the output just vanishes because the signal on both houses is the same. It just vanishes. It works perfectly now. So yeah, that's it. It's got ECC83 or 12AX7s, whichever one you want to call it. It will work. This gives about 100 dB again at full volume. It can run with 12. Is it an AT7? The ECC81. I think that's a 12AT7. Yeah, slightly lower gain. It runs at about 32 dB of gain with them. So yeah, I'm still just waiting on loads of issues with backorder stuff. So I just ran some 100 picofarad caps on here. There, the frequency compensation, stop it oscillating. Also high frequency shunt off. So yeah, this heatsink has the pass transistor for the HT regulator and the 48 volt regulator on it. It's on the other side. This heatsink has the transistor for the 30 volt regulator on it. This op amp down here is the op amp which then gives the 15 volt bias supply for all the other op amps. And this transistor here, that's the 12.6 volt heater supply, minus 12.6 volt. These caps are massively large between the valve stage, and they could have just been 10 microfarads for frequency purpose. Realistically, they've only got a few volts across them. However, should the valves develop a fault, it will turn these transistors on fully, and then there'll be 160 volts across these caps. I wanted them to survive, not pass any DC, so it didn't damage this stage. Ideally, 200 volt caps would have done. However, with things the way they are, the only values I could even come close to getting it anytime soon from my usual suppliers were 400 volts. So 400 volt 10 microfarad caps it was. So yeah, there's a hell of a lot of different values of components on there. Some of it isn't quite true to schematic I use. So some of these small transistors are like BC550s, some are MPSA 42s, 92s, depending on voltage. But yeah, that's, in a nutshell, that's it. That is an incredibly awesome, low distortion, low noise, high fidelity microphone preamplifier with 2 inputs and 2 outputs. So next thing to do is to start work on the case. So yeah, anyway, if you'd like some more info, actually like a better made video on this, then please do comment, and I'll take the time to bother making a good video. And as always, if you have actually watched this, thanks for watching, and catch you again.